Ladies and gentlemen, I would like to welcome you to the 2011 Energy Summit. We have prestigious scientists here from across the state of Maryland representing the biomass energy field, fossil fuel energy field, nuclear and geothermal, solar, wind, and hydroelectric power. Our task today, as you all know, we have been tasked by the Energy Information Administration from Maryland. We know that the population of Maryland is growing and we do not have enough energy resources to supply them the energy they need. Our task today is to decide which group to go forward with and to push Maryland to develop that form of energy. I would like you to think about the RFP and the constraints that we have for the RFP. On the left side, you're going to fill in how does the developing this source of energy meet the constraints of the RFP. Just in case you don't remember them, I've placed copies of the constraints in the center of your table. Please leave them here when you leave. And then on the right-hand side, what are the drawbacks to choosing this form of energy for further development? So as you speak, I would like the groups to touch on each of those aspects. I would like it if you have a comment or question, introduce yourself as they would in a professional meeting. Just say your name and who you're with. So if I were in the biomass group, I would say Mark Kramer, biomass, and then ask your question.
So we are doing we're doing nuclear energy. It meets the constraints because if you look on your alternative energy RFP constraints, it asks if it is a renewable form of energy harnessed using existing technology, which we have the technology to do it, so that meets that constraint. It is targeted at increasing the amount of energy available without any adverse impact on the environment, which means it does not hurt. It does not. It doesn't hurt the environment.
Excuse me?
And yes.
You said it.
Sir, can you say your name and what coalition you're with?
Adam Levy from Wind, and you said it does not have an adverse impact on the environment, but before you said it was radioactive. And if it's radioactive, it obviously has an adverse impact, because even if it is stored inside, you're going to run out of room. And look what happened with Japan. Like, if something comes in and one little bit escapes, it can destroy a lot of things.
That's why they have fuel rods, or known as control rods. Control rods, let's see. Fuel rods and moderators, control rods, make sure the reactants don't go too fast. They lower into the reactors because if the reaction goes too fast, it can cause an explosion which releases all the radioactivity stored inside. So that's why they have the fuel rods.
Excuse me, I'm John from Geothermal. What happens if a nuclear meltdown happened like in 3 Mile Island?
Then that would cause an explosion which would release the radioactivity.
So that does have an adverse impact.
If it explodes, yes. Otherwise, it releases.
You didn't tell the rest of the group how we get from that energy when you're splitting or fusing a nucleus of an atom to the electricity that the people of Maryland need. How are we going to get to those two steps? Either not Melanie, but Chiron or some of the other group members. Emma or Jordan, can you answer that?
Well, the nuclear power uses the energy released when atoms of uranium or plutonium are split to generate the electricity.
How do we generate it from the energy from an atom? How do we get it to electricity that's going through our wires?
Well, when the atoms explode, they're under a huge bunch of water, like a huge tank of water, which then the explosion heats it all up, and the steam comes and blows it to a turbine, which spins the generator and generates electricity.
Outstanding nuclear coalition.